Hello. So this screencast practically demonstrates the use of SPSS for conducting the Fisher's exact test. And I wanted to show an example that uses this retracted paper about um, Roundup herbicide and genetically modified maize and its effect on mice and tumors in mice. So this paper was retracted due to people that objected to essentially the use or lack of use of statistics, and it really comes down to the conclusions of the authors. And no one really accused the authors of fraud or any problem with the experiment itself, but it was their conclusions. And in a letter to the editor, someone wrote in and demonstrated with the Fisher's test that they could have come to different conclusions if they had used proper statistics. So, and they address this claim that the authors made. If we look at the abstract, the second sentence says, in females, so this is the paper itself, long-term toxicity of Roundup. It says here, in females, all treated groups died 2 to 3 times more than controls and more rapidly. But they don't say whether that's statistically significant or not. So someone wrote into the letter, wrote a letter to the editor, wrote into the journal and said, Seralini et al. State that in females, all treated groups died 2 to 3 times more than controls. As followed from the figures presented, 2 females out of 10 died before the mean survival time in the control group, compared to 29 out of 60 in the 6 GMed fed groups. Now, if we look at these numbers, we can actually put them into a 2x2 table format, a contingency table format. So let's see if I can find that here and just show you that contingency table. So here it is, female GMO data. And I'll get that out of the way. Actually, now this is a data set. This isn't a 2x2 format, but this is the data set that I want to import into SPSS to actually do the analysis using SPSS. Here's the table in a contingency table format. So those are males, females. So if we look at the article, or if we look at the letter to the editor, 2 female rats out of 10 died. So here are the 10 in the total column. 2 died. Death, 2. That means 8 didn't die. 29 out of 60 of the GMM fed group died. 29 out of total 60 of the GMM genetically modified maize group died. So see, this is how we take these counts and put them in a 2x2 table, and it's clear that what we're doing is comparing proportions between groups, or another way of stating that, trying to determine whether genetically modified maize, whether the maize is genetically modified, contributes to death. So is there an association between genetically modified maize, yes, no, and death, yes, no? We can put this in a data set format like this, where we have individual mice, 1 through however many mice we have, and in this case there were 70 mice total, 60 on the genetically modified diet and 10 in the control group. And we have 2, 0, 1 variables here: genetically modified maize, 1 if they ate it, and 0 if not. And then death, 1 if they died, and 0 if not. So I just put this table, I put this data set together based on the numbers in this letter to the editor. Okay, now let's open SPSS and do the Fisher's exact test. So I have an instance running here, and I will import the data, open data, and I need to find the data set. So it's an Excel file, so I'll select Excel. And here it comes up GMO female data. So here's the data set. These should be numeric variables, so let's look. They're all numeric, that looks good. So now we're ready to do the Fisher's exact test. And we can go in Analyze, Descriptive Statistics, Cross Tabs, and we have rows and columns. So cross tabs refers to the table cross-tabulating two variables. So one variable will represent rows, just like we saw in the 2x2 table here. So the rows will be genetically modified maize. The columns will be the death, yes and no. And let's look at exact. Asymptotically only, we'll just put exact and limit it to 5 minutes. Okay, statistics. And we'll do the chi-square. Okay. And I believe it'll do the Fisher's. It will also do the Fisher's. Okay, so here we see the table of results. Fisher's exact test, here it is, exact test. One-sided here, 0.09, and two-sided, 0.168. Now let's look back in the letter to the editor and see what he got. P is equal to 0.09. So we got the same thing from Excel and writing out this little data set as the person who wrote in. Of course, 0.09 is greater than 0.05, so even if they had only done a one-sided, not the more stringent two-sided, they still wouldn't have gotten a significant result if they had set it up this way. Also, in the table, we see the Pearson chi-square with the Yates continuity correction, and it's presented both one-sided and two-sided. And the results are essentially the same here. Thanks.